Hey yo, it's FRQ Fawkes, and today we're going to do a Unit 4 Linear Momentum FRQ 4. So let's get started. In Scenario 1, a student sets up a track with a ramp that smoothly connects to a horizontal surface where two blocks, Block A and Block B, are located, as shown in the figure below. The student pushes Block A of mass ma so that the block travels with velocity vi. Block A then collides inelastically. Remember that inelastically right here means sticking together. With block B of mass MB, where MA is greater than MB at rest, as shown in the figure. Blocks A and B stick together. There's what inelastically means. Then travel up a ramp, reaching a maximum height of h1. So we're given scenario 1 right here, so we can just annotate the figure. Of course, in the actual exam, you can't annotate a digital copy. So I recommend you could just draw this out on a piece of scratch paper to help you understand the situation better. Because all what physics comes down to usually is how much do you understand the situation that's provided. So I'm just gonna annotate. See, they stick together right here. I'll put MA and B. And the moving some velocity, I'll put VF. And then they come over here. They reach a height, what does it say? H1. And I'll write this is MA, and this is MB. Then for sake, I'll just say this is MA. Also, another important thing to note is that MA is greater than MB. So I'll just write this right here to make sure we remember that. Now let's read the second part. In scenario 2, the student sets up the same track but swaps block A and block B. The student pushes block B so that the block travels with velocity vi. Block B then collides inelastically with block A at rest, sticking together. Both blocks travel up the ramp and reach a maximum height of h2. So we can just also draw the scenario again. We'll just draw it under here. So in this case, we just have MB also moves the same vi. I'll draw the cool lines back here. And then they collide together. So we have MB and MA. They move some V. I'll put VF1 and VF2 since they might not be the same. They could, but we don't know yet. And then they travel up this ramp and they reach H2. So I'll write that this is scenario 1 and this is scenario 2 since you don't want to mix those two up. So now that we put the words of the problem into the picture, let's go on to part A. Indicate whether h1 is greater than, less than, or equal to h2. And then we have justify reasoning. So, in this one, what's the difference in the problem? There's one key difference between these two scenarios. It's that the masses of the blocks are different and that they're swapped. So as we know, we can look at what's different and see how that will affect the scenario. So we see that MA is greater mass and moving at VI, and they have MB moving at VI2. So what does a different mass mean in the scenario? It means that block A will have more kinetic energy than block B. So I'll write that out of these two, I'll use a different color. So out of these two right here, block A has greater kinetic energy than block B. So let's see how this affects the rest of the situation. So now the two blocks collide, and how do you think that affects it? Well, it could affect the final velocity, but we can't really think about it ahead. What we do know is that energy is not really lost. So we know that it must be put somewhere. Of course, when two things stick inelastically, it does mean some energy is lost. But if there's more energy in the first place, that means more energy will be continued for the velocity. So that means that the velocity of v1 will be greater than the velocity of v2. And now for the final part, how will this affect the height? Well, this is back to conservation of energy. If you have bigger velocity, you're going to go higher. And since they're the same mass, that's the only thing that depends on it. So now we can indicate with these two that h1 is greater than h2. So now let's actually write this down on the final part. So we have h1 is greater than h2. Then now let's justify. So how we're going to justify is just go through how we did in order, chronologically. So you can say, since MA is greater than MB, scenario 1 has greater energy than scenario 2. And now we can just say this means that after the collision, the blocks will be moving faster. Blocks will be moving faster. We can also think of that as even though energy is lost, it's not like it's going to be still proportional. The blocks will be moving faster, although energy is lost. Just so it shows that we understand what inelastic means. And then now we can bring this all together with actually answering the question, which is the height. Greater velocity leads to greater height. We can just say due to conservation of energy. Due to conservation of energy. And that would be enough. Now we can go into part B. Of course, let's say you didn't get part A. You can always just do part B, then do part A. The only thing you have to know about that is part A, I don't think you can ever use equations for that one. I'm 90% sure. So just have that in mind that part A, you have to explain it conceptually. Then part B, you can actually use the math. So let's go on to part B. Derive an expression for the maximum height, h max, in scenario 1 of block A and block B. Express your answer in terms of MA, MB, VI, and physical constants as appropriate. Begin your derivation by writing a fundamental physics principle or an equation from the reference sheet. So now we can just kind of like deconstruct what we did here. So in this case, we have initial velocity, MA and MB. So we could find the kinetic energy of the first blocks, but will that actually matter in this equation? No, because we start with conservation of momentum. We don't need energy for that. So we can just start with conservation momentum, which is net PI equals net PF. The reason why I'm actually writing this out is because the scoring guides will have a simple point for writing conservation momentum, writing even the words conservation momentum. And all questions have that. If it's in forms of, oh, law of conservation of energy, just write energy initial equals energy final. If you're force balancing, just write Newton's second law, or write F equals ma. Just write a very basic thing, which is a basic fundamental principle, or something from the reference sheet, which you can just write basically anything that's on here. I would recommend writing it like exactly how it is, just to be safe, because you never know if you have a mean grader or a nice grader. So now let's finish this. So now we can kind of carry on with, we can just substitute P for what actually is momentum. Now we can continue. MA equals MAVI equals MBV. We can just use VF for final velocity. VF plus MAVF. In this case, we're trying to solve for VF because we want to carry out with doing it for conservation of energy with kinetic energy to velocity. So we're just going to group the VF together, get out the MA and MB, and then just divide it. So that's exactly what I'm going to do. And now we've solved for VF. Now we can go on to conservation of energy. So now we can just write EI equals EF, and we can be a bit more specific by saying the initial kinetic energy will equal the final gravitational energy. So now we got to actually use our formulas. If you don't remember it, you can always come here. You have the kinetic energy right here. Gravitational potential energy is written really weird on here. I would just say, like, ignore the delta. So now let's go back and substitute all of our stuff first. So we can say 1/2 mvf squared equals mgh. Of course, we have to do a bit more substitution. So I'm going to bring this up here so we have ample space. So first, what is our mass? First, the mass actually cancel out. So don't have to worry about it. Since the masses are the same for kinetic energy to potential gravitational energy, masses cancel out. That's great. But now we have, what's the final velocity? Well, we have it right here. So I can just say, oh, substitute that in too. So we have 1/2 MAVI over MA plus MB squared equals GH. probably specify that this is H max. And then now we can just simply divide by G. So we have 1 over 2G, MA VI, MA plus MB squared equals H max. Of course, you can distribute the square to get MA squared VI squared over MA plus MB squared. Perfectly that, but it looks cool this way. It's the same answer. So I'd recommend boxing your answer to make it clear on what your final answer is. So now on to part C. Indicate whether the expression for the maximum height, h max, you derived in part B, is or is not consistent with the relation you selected in part A. Briefly justify your answer by referencing your derivation in part B. So first, let's just go back and see what part A was asking. It's asking which height is greater. Now we can use the equation to actually do it. So first, what's the difference between scenario 1 and scenario 2? That scenario 1 has greater MA and MB. So I'll just write that right here to make sure we remember. MA over MB. Then now let's use this equation to justify. So in scenario 1, MA is on the top. However, in scenario 2, instead of having MA here, we would have MB here. So then how does that change it? Well, MA is greater, which means that H max will be greater as the whole squared thing is greater. Everything inside the square will be greater. But with MB up there, everything will be less because MB is smaller than MA, making that whole thing inside the square smaller, therefore making H max smaller. So we can kind of just use that reason. So we can just literally start off with this. The equation that I derived in part B. The equation I derived in part B has the mass. I can say like the mass of the initial pushed block on top, I'll say on top in the numerator. That's just a brief description, and then explain like how that affects it. Since MA is greater than MB, and in scenario 1, MA is initially pushed, this will lead to a greater H max than in scenario 2, as MB is less than MA and is initially pushed. This is a bit wordy, but it gets the meaning across. Now let's say you don't understand why that appears over part C. You can actually just get a point by stating a certain relationship. If you don't know it, just state a random relationship that's probably at least somewhat relevant, and you can just get a point for that. So yeah, the main ways you can get points. If you don't know, just try your best, and you probably will get some points. Well, that was it. Thank you for joining me, and I'll see you next time on Future FRQs. Goodbye.